This is a brief review of significant figures, how to identify the number of significant figures in a measurement, and how to do calculations with significant figures. So significant figures only comes into play when we're talking about measurements. So it gives us an idea of how precise a measurement is, which is a reflection of the equipment itself. Okay, the more precise a piece of equipment is, the more significant digits your measurement will have. So, for example, a graduated cylinder, which has smaller increments to measure volume, will be more precise, and therefore a measurement will have more significant figures than a volume measured in a beaker, for example. So how you can tell is you look at the number or spacing of increments on the piece of equipment or glassware, and the more increments you have, the more precise of a measurement you can make, and therefore the more significant figures your measurement will have. All right, so just to kind of give you a feel for the difference between precision and accuracy so you don't mix them up, accuracy is how close your measurements are to the actual target value or the actual value that you're trying to reach or measuring against. Precision is how repeatable a measurement is. Can you repeat this measurement and get very close to what you had the last time? How reliable it is. So let's look at these graphs for a moment. The first one, if you just take the simple average of these values, you're going to get a number not too far off. If you say the target is 10, you're not too far off. But if you don't tell your readers or your audience what the individual values were for each of the four measurements, they're not going to know how much scatter or what a broad range you had. And that's important because if you have a scattered range or broad range like this, that means that the measurements aren't really very reliable, okay? Your precision is not very good in that one. All right, so in this case, you have excellent precision. Look how repeatable the values are. But this shows that there's a problem because all of your measurements are off from the actual value by a significant amount. And that could happen, for example, if you have a piece of equipment that needs to be calibrated. And then finally, ideally, here you have a situation where your measurements are very repeatable. That means you have good precision, and your average is also right spot on to the target value, so your accuracy is good too. All right, so I said this before, it's worth emphasizing. The more significant figures you see in a measurement value that you're given, the greater the reliability and precision of the measurement is. So quickly go over the rules for determining what figures in a measurement are significant, what are not. Any number that's not a zero is automatically significant, okay? Any zero that is trapped in between two non-zero numbers is also significant. If you hear heavy breathing in the background, it is my dog trying to get me to play fetch. All right, so when we get to zeros, that gets to be the somewhat tricky thing in determining sig figs. All right, so leading zeros, that is zeros at the beginning of a number, like to the far left, before any non-zero numbers start. Leading zeros are never significant. Now, I've noticed with students in the past that some people think leading zeros have to be on one side of the decimal or another. That's not the case. It does not matter where the decimal is relative to leading zeros. Any zero that becomes first in a number before a non-zero number is leading zero, and they do not count as sig figs. They're just placeholders. All right, so in this case, I kind of mutilated this now, but that has two sig figs, and this one only has one sig fig. Alrighty, now the most important rule is number 4 here. And if you only went by one rule, that would be the one I would tell you to pay attention to, and that's trailing zeros. Okay, so trailing zeros are any zeros that come to the far right of a number. Okay, again, it doesn't matter where the decimal is, any zeros that are shown to the far right, okay, are trailing zeros. Now, sometimes they're significant and sometimes they're not, and that's the tricky part. Okay, it turns out that if there is a decimal any place in the number, any place, doesn't matter if it's before, after, in the middle, whatever, that means that all of the trailing zeros are significant. If there's a decimal any place. So you can see 4 sig figs because there's that decimal. If I were to rewrite 1,000 without a decimal, that would only have 1 sig fig, okay? So decimal's really important. So any number like this, 14,000, that has no decimal, all the trailing zeros again are a placeholder, and this would only have 2 sig figs. Okay, and then finally, if you have scientific notation, it's kind of nice because all of the digits in the coefficient of scientific notation are significant. Now, of course, the exponent has nothing to do with precision of a measurement, so don't consider anything to do with the exponent when you're counting sig figs. Alrighty, so before we go on and do some practice, it's worth pointing out there are some numbers that are not measurements, and we call them exact numbers. So basically, anything that you can count, like 1, 2, 3, 4 of something, is not a measurement, right? So that is an exact number. It doesn't make sense to talk about significant figures. So, for example, you have 10 toes. You have exactly 10 toes. You don't wake up one morning with 9.4 toes, and you don't wake up another morning with 10.3 toes. You have exactly 10 toes all the time. So toes, the number of toes is an exact number, okay? It's never going to change. And so it has unlimited or infinite number of sig figs. And so if you're doing a calculation and you're trying to keep track of how many sig figs each factor has, you just ignore the exact numbers. They don't limit your answer in any way. And then finally, most conversion factors are treated as exact values and not taken into consideration when you're determining sig figs. The one big exception to that is molar mass, okay, because molar mass, they are measured values, and also it's important when you use molar masses from the periodic table that you carry enough significant digits. So, for example, instead of writing the molar mass of carbon as 12 grams per mole, like instead of rounding to a whole number, you should carry at least 2 digits to the right of the decimal for every molar mass you use, because you don't want the molar mass to be your limiting factor in sig figs for a calculation, because it's known with a high level of precision. So I always recommend carrying at least 2 digits to the right of the decimal with molar masses. All right, so if I were to ask you, if I were to give you these 2 values and said, okay, tell me about the difference in those 2 values. Are they equal to each other? Is one telling us something that another one is not? What all could you think of to say if you compare these 2? Well, hopefully you would say that this is the more precise measurement because it has more sig figs. And if you're not sure about that, look back at the rules I just showed you. These trailing zeros count as sig figs because there is a decimal. So this value has 3 sig figs, and this has only 2 sig figs, which means whatever equipment was used to give the 4.00 is more precise equipment than the other one. And that means the measurements you make on this piece of equipment are going to be more reliable, more repeatable. All right, so every measurement has a degree of uncertainty in it, okay? And the degree of uncertainty is reflected in the digit to the far right of the number. So for example, if you have a measurement of 4.0, there's uncertainty in that last digit. So in actuality, the value could be 3.9, it could be 4.1, etc. So often precision is expressed as a range, okay? So I'm sure you've seen these, for example, 4 plus or minus 0.1. But again, that precision is in the digits that is to the far right of the number. And to compare the other value that we decided was more precise on the last slide, 4.00, the uncertainty in this value is in the hundreds place, not in the tens place. So it would be plus or minus 0.01 for the uncertainty instead of 0.1. Alrighty, so one of the things you should be able to do in addition to doing calculations with significant figure measurements is you should be able to look at a piece of glassware or equipment and be able to make your own measurement with the correct number of sig figs that reflect the precision of the glassware. So let's look at this one for example. All right. So first of all, if you have a meniscus like we do here, that sloping curve, you want to make sure that you measure volume at the base of the meniscus. I just noticed I didn't do very well there. Okay, and so that, maybe around there or something. All right, so now let's talk about how to do this measurement. The first thing that you want to do is you want to write down what you know for sure, okay? And you will always know for sure that your volume or whatever you're measuring is in between two values, okay? So look at this graduated cylinder and see the bottom of the meniscus is for sure between what two values? Well, it's between this increment and that. So see what those are. You might notice that, let's see, 4.1, 2, 3, 4, 5, 6. So that is clearly between 4.5 and 4.6. So we know that for certain. Okay. When you determine the number of digits that you know for certain, you're going to add one more digit to the far right. So you're going to add one more digit here, and that is going to be the digit in the measured value that has some uncertainty. And so that's going to vary depending on the person who's measuring it. So now what you want to do is you want to look back in between those increments you've decided it's in between, and you want to estimate where the bottom of that meniscus lies relative to those two lines. So I might say, let's see, to me that looks like 4.57, okay, milliliters or whatever, okay? So somebody else might say 4.58, 4.59, so there is going to be some uncertainty in that digit. So that's what you're going to do. Write down what you know for sure and add one more digit. All right, let's test it out and see how you do on these. So I would recommend turning the video off and seeing if you can say how many sig figs are in each of these values, and then turn it back on and I will explain them. All right, so the first one's easy. 3 sig figs, they're all non-zero numbers. This one may have tricked you, okay? 7 pennies. Pennies are something you can count, okay? You're never going to come up with 6.7 or 7.3. You're going to have exactly 7 pennies all the time, okay? That is an exact number, as anything you can count is. So it has infinite number of sig figs, which means you can pretty much ignore it. All right, so this number is in scientific notation, and so you simply count all of the digits in the coefficient portion, which is 3. D has a bunch of leading zeros. You always ignore leading zeros, so this only has 2 sig figs. E has a decimal in it, which means that all the trailing zeros are significant. So every single digit in this number is significant. That leaves you with, oh, I didn't say, did I? That's 5. Okay, anyway, that has 5. And the very last number, there is no decimal point, and so we can't count those as sig figs. So this one only has 2 sig figs. All right, one more for you. Pretend like this was a multiple choice on a quiz or test, and try it yourself first. I'm hoping that you see this one. The first number only has 1 sig fig. This one has 5 sig figs. And this one has 3. Alrighty, so now we're going to talk about adding, subtracting, multiplying, and dividing, and keeping track of how many sig figs the answer should be reported with. So multiplication and division tends to be the easier one to remember. But man, like almost half students seem to mess up on the sig fig rules for adding and subtracting. So when we get here, pay special attention. Okay, so multiplying and dividing, you basically just count the total number of sig figs in both of the or all of the factors that you're multiplying and dividing. And the one that has the fewest sig figs is going to determine how many sig figs your answer has. So, for example, if we multiply 50, there's no decimal here, so that's only 1 sig fig, by 13, that has 2 sig figs. That means your answer can only have 1 sig fig, okay? Because it's always the weakest link, isn't it? All right, so what you get out of your calculator is 650. That has 2 sig figs. Not good. We have to report this answer with 1 sig fig. How do we do that? Well, we can only keep this first value. So now we come to another point, and that's when you're working with sig figs and doing calculations, you have to know the rules of rounding, okay? So you determine what's the last value you're going to keep, and then look 1 digit to the right. If that digit is 5 or more, you are going to round up. And that's how we got this, okay? If the digit to the right is 4 or less, you would have kept it as 600, okay? So those rounding rules are important. Give you a little bit better feel for it. If I had told you to round the following values to only 2 sig figs, make sure that you understand each of these, okay? So what you do, you can have 2 sig figs. So you count off starting from the left, 1, 2. That means this one has to go away, but not until you determine which way you're going to round. So we're going to look at the 7, and that tells us we have to round up. In this case, the number to the right is a 4. So we're going to just keep it 5.3. Never round down, okay? That's no. You're either going to keep it the same or you're going to round it up. 5.35, there we go. As long as it's 5 or greater, it's going to round up. And in this one, 2 sig figs, you only look 1 digit to the right, and that's a 4, so you just keep the number. Now, the reason I added this particular example is because some people, especially if you're doing your GPA, may be tempted to move over maybe to the second digit to the right from the sig figs, and you could kind of convince yourself perhaps, well, this 9 will change this 4 to a 5, and then this 5 will change this 3 to a 4. No, okay? You can only look at the digit immediately to the right of the last sig fig. All right, so now if you're kind of spacing out or not paying attention, now's the time to listen. If you are adding and subtracting numbers that are measurements and you want to be sure to report the answer with the correct number of sig figs, what is important for adding and subtracting is the number of decimal places, okay? The number of digits to the right of the decimal. So, for example, this number only has 1 digit to the right. This number has 2 digits to the right. Since you're adding them, what that tells you is your answer can only have 1 digit to the right of the decimal. So what your calculator is going to give you, 72.63, and of course this has 2 digits to the decimal. You cannot keep this one, but make sure that you follow the rounding rules. Since it is 3, the last significant digit of 6 just stays at 6. Okay? Now, some people, when they're adding and subtracting, arrange the values in a vertical, like you used to do in grade school, learning to add and subtract, because it's easier then to see which of these numbers that I'm adding or subtracting has the fewest digits to the right of the decimal. You identify that, then you draw a vertical line, just to remind you all the way to the answer how many digits to the right of the decimal you're allowed to have. Then go ahead and just add them all up, have too many digits to begin with, so that you can round correctly. And realize that you can only keep the 0.41. Make sure you don't have to round up, and then those go away. Okay, same thing here. Your answer is only going to be able to have 1 digit to the right of the decimal because of the 5.9. But go ahead and subtract all of the digits again so that you round correctly. In this case, we can keep the digit to the right, immediately to the right. And then to the right of it, the first one we're getting rid of is a 7. So we do have to round up in this case. Now, the most difficult problems, at least I think the most difficult, I make so many errors in them, is when you're combining operations. So, for example, in this case, we're multiplying, and then we're subtracting, then we're multiplying both of those, and you've got to keep track of all the different rules so that you know how to report your answer. So I'm going to walk you through this one, and there's one for you to do on the last page. .069 times 30 plus 890 divided by 277. Alrighty, so I just rewrote it here. Always, of course, math operations do what's in the parentheses first. I'm going to, as I always do, include a bunch of extra digits until the end. All right. And let's see, 899.3208 divided by 277.00320. All right, 3.2466. All righty, so let's now, before we do the final calculation, keep track of how many sig figs everything has. This number has 6 figs, and this number has 4. So the answer to this in parentheses can only have 4 sig figs. Okay, that's just so we can keep track. And let's see, here we're dividing, which has the same rule. So let's count sig figs. 1, 2, 3, 4, 5, 6, 7. That has 7 sig figs. 1, 2, 3, 4, 5, 6, 7, 8. That has 8. So that means your answer needs to have 7 sig figs. 1, 2, 3, 4, 5. Guess what? I didn't carry enough. I'm going to add a couple more. Okay, 7. 1, 2, 3, 4, 5, 6, 7. Okay, that's it. All right, so now you're adding these. So I'm going to go ahead and arrange them vertically again. You can just punch them into your calculator if you want. I just like the visual effect this gives. All right, we're adding, aren't we? Yeah. All right, and so when you're adding, what is important is the number of digits to the right of the decimal. So the first number, there's only one digit to the right of the decimal if you're talking about sig figs. And the second number, we had a bunch of them. Let's see, 1, 2, 3, 4, 5 to the right. So this is significant all the way to here. Okay, but the one with the fewest is always what limits everything. So I'm going to go ahead and draw this line to remind me, and that's my dog trying to play again, where the last significant digit is. So I'm going to go ahead and add all these together, though, and do my rounding at the very end. So let's see, if I put that in my calculator. Okay, so Grace says hello. Okay, then this answer, 395.76044. And let's see. Now let's go ahead and round correctly. We can only have one digit to the right of the decimal. Okay, so that's our last significant digit. Now we've got to follow the rounding rules, so we look 1 to the right. That's 5 or greater, so that means we have to round up. So your final answer is 395.8. And that's it.